Hi everyone, so here's the solutions to Chapter P Review 2. So when you're factoring completely, if you have two terms and they're both perfect squares, you should always try to do a difference of two squares. Okay, so let's check this out. And notice, you guys, that this is a minus, which is a difference. Remember, that does not work for a sum. Okay, so I need two things that when I multiply them, they're exactly the same, are going to give me x to the fourth. Okay, we know that x squared times x squared is x to the fourth. Now the next one's a little bit big. Remember, one's going to be a plus, one's going to be a minus. 625y to the fourth. Well, what times itself gives us 625? That is 25 times 25, but then we still need this y to the fourth, so it's going to be y squared and y squared. Now you guys, every time you finish factoring, I want you to think, can I factor more? So because this is a plus right here, that is a sum of two squares, I can't do that one. But because this one's a minus, I can actually factor this one a little bit more. So this would be x plus 5y and x minus 5y, another difference of two squares. And then you guys, this one, since it didn't factor, it just kind of drops down and tags along for the ride. All right, so here's the answer to number 1. All right, number 2, what do you see? I see 4 terms, which means it's probably going to be grouping. But you guys, before you even group, see if it has a GCF. Is there a number that goes into all of these guys? No, there is not. So I can go ahead and start grouping. Okay, grouping the first two. What can I pull out of here for a GCF? I can pull out a 4 and an x. Remember, when you're pulling it out, you're pulling it out by dividing. So 4x squared divided by 4x gives us x. 12x divided by 4x gives us 3. And you should be able to double check it every single time by multiplying back, right? Okay, now let's look at the next one. Plus, bring down the plus sign. What can I pull out of these two? I can pull out a 3 and I can pull out a y. And let's see if we have left over. So if I pull out a 3 and a y out of here, I just have an x left over. And if I pull out a 3 and a y out of here, I'm just going to have a 3 left over. And again, if you distribute that, you should get that back. So always check that out. Now, here's your first check for understanding. If the stuff in the parentheses is the same, that means you probably did it right and it is a grouping problem. So I can pull out another greatest common factor, which is the x minus 3. Because they both have that in common. If I pull the x minus 3 out of here, I'm left with the 4x. Plus, if I pull out the x minus 3 out of here, I'm left with a 3y. And again, if you have time, you can FOIL these out and check to make sure that it gives you the original question back. Great way to check your answers. Okay, number 3. Okay, whenever you see cubes, okay, it's probably going to be a sum or difference of cubes. So let's see if we can do this one. So first, I need to rewrite this as something cubed minus something cubed. Now, you guys, this first number, 216, is a little bit too big for me. But what times itself 3 times gives you 216? That is 6. And then what times itself 3 times gives you y cubed? That would be y. And then the 125, that's one that I told you that you need to know. So it's going to be 5 and then x. Okay, now let's go ahead and construct this. Okay, so you're going to have a little parenthesis and you're going to have a really big parenthesis. Okay, to get the first parenthesis, you're just going to cross off these 3's, and what you're left over is 6y minus 5x. Okay, now let's do Mr. Happy Face here. Okay, that's your I. What do we do to i's? We square them. 6y times 6y is 36y squared. Then we change the sign. This was a minus, so this is going to be a plus. Then we do the happy face. 6 times 5x, 6y times 5x is 30xy. You can write 30yx, but I just like to do an alphabetical order. This last sign is always a plus. And then the last I, we square the i's. 5x times 5x is 25x squared. Barely fits in there. So all of this ends up being your answer. And you guys remember, on these sum and difference of squares, this last trinomial, it never factors. So please don't try to do like a big X or a big star on it. It just won't work. You just gotta trust me on it, okay? All right, number 4, a little bit easier. You've got 3 terms with the 1 in front. Allie, you're good. Go ahead and open the door. Yeah, you're in my video. Sorry. Okay, so you have big X. I need 2 numbers that multiply to make 18 and add to give me -3. That would be 6 and -3. How lovely is this problem? So this is going to be x plus 6 times x minus 3. Oh, I did that wrong. Silly me. Let's try that again. Okay, 6 minus 3 is not negative 3. It's negative 6 plus 3. Do you see how easy it is to make a mistake? So this is x minus 6 times x plus 3. And you guys, the only reason I caught that mistake is because as I was writing it down, I'm thinking about, like, is it right? Okay, so just, like, keep thinking, okay? Don't ever let, like, your brain just go and just write down whatever. All right, number 5. 3 terms with a leading coefficient, something that's besides 1. This is going to be big star. Let's do it over here. So I need 2 numbers that multiply to give me 3 times negative 5, which is negative 15, and add to give me this middle term, which is negative 2. So that would be negative 5 and 3. Then I'm going to divide by that leading coefficient, divide by 3, divide by 3. Okay? Hey, you guys, negative 5 over 3 does not reduce anymore. So I've got x minus 5 over 3. And then 3 over 3 reduces to a lovely 1. So this is just going to be x plus 1. But we don't want to leave our answer like that. That looks dumb. Take the bottom and move it up. So this is going to be 3x minus 5 times x plus 1. Okay? All right, last factoring question. Okay, this one's all messed up, okay? Let's write in descending order first. That means biggest exponent first. So the first term is negative 16x squared. The next term is negative 20x, and the last term is positive 24. Now, you guys, I'm looking at this going, these numbers are really big, okay? That's a huge hint that this may be a GCF. So what is the biggest number that goes into 16, 20, and 24? I believe that's 4, but I'm also going to pull this negative out with it because you never want your x squared term to be negative. So I'm going to go ahead and pull out a negative 4 as a GCF. Now remember, when you're pulling something out as a GCF, you're actually dividing it out. So let me write that out because of the negative sign. It might be kind of confusing. So for the first part, negative 16 divided by negative 4 is just positive 4x squared. The second part, negative 20 divided by negative 4 is positive 5x. And then the last part, 24 divided by negative 4 is negative 6. Now again, ask yourself, can I factor more? You can. What you have left over here, this is another big star. So let's go ahead and do it. Do a big star. I need 2 numbers that multiply to give me negative 24 and add to give me that middle term, which is 5. So it's going to be 8 and negative 3. Divide by your leading coefficient, which is a 4, and let's go ahead and do this. So you have negative 4. Don't forget this GCF. It tags along, right? Okay, your first factor, 8 divided by 4 is 2, so it's going to be x plus 2. And then the next one is this negative 3/4 x minus 3/4. And you guys, we don't like the way that looks. Remember, if you ever have a bottom of a fraction, just move it up. So this is actually going to be negative 4 times x plus 2 times 4x minus 3. Alrighty? Awesome. Okay, now guys, this next little section here, there's so many different ways you could do it, okay? But I'm just going to do it the way that you guys found it the easiest. It might not be the most efficient way, but it definitely works and I think kind of makes sense. So look, I'm raising everything to the negative second power, okay? So I'm going to go ahead and write this out. So this is 4 to the negative 2. And then x to the, now look, if you have a power raised to another power, right here, you're going to be multiplying these two numbers. So negative 3 times negative 2 is a positive 6. And then all over, raise all of these guys to the negative 2. So you're going to get 3 to the negative 2. And then again, you have a power to another power. That means multiply. 5 times negative 2 is negative 10. Okay. Remember, we don't like negative exponents, okay? So let's ask ourselves who needs to move, okay? So for the first one, 4 to the negative 2, that's a negative exponent. That means it needs to move down to become positive. X to the 6 is good to go because it's already positive, so I'm going to leave it where it is. 3 to the negative 2, that's a negative exponent. It needs to move. So if it's down below, it's going to move up above, which is 3 to the second. And then x to the negative 10, again, it's a negative exponent. It needs to move back up, so it's going to be x to the positive 10 on the top. And now let's just make it pretty. So 3 squared is 9. These guys, when you're multiplying, remember, you add those exponents, so it's going to be x to the 6 plus 10 is 16. And then on the bottom, 4 squared is 16. All right? Okay, number 8 is just a more complicated version of that, so let's go ahead and do number 8. All right, raise everything to the negative third power. Remember, power to power, you multiply, right? And you guys, if you notice, all of these are power to power, okay? So the first one's going to be 8 to the 3 times negative 3, which is negative 9. Then we're going to have x to the negative 3 times negative 3, which is x to the positive 9. And then we have y to the 4 times negative 3, which is y to the negative 12. Do the same thing on the bottom. Negative 5, raise everything to the negative 5. So on the first one, we're going to have 8 to the 4 times negative 5, which is negative 20. Then we're going to have 2 times negative 5. That's going to give me x to the negative 10. And then we're going to have 7 times negative 5, which is going to give me y to the negative 35. Okay, if this isn't ugly, I don't know what is, okay? So look, let's fix the negative exponent issue. So let's see who can stay and who can go. That's a negative exponent. It has to move to the bottom. This is a positive exponent, so it can stay. This is a negative exponent, so it moves to the bottom, okay? Now, this is a negative exponent. If it's on the bottom, it has to move. Where can it move? The only place it can go is the top. This is another negative exponent. It has to move to the top. And another negative exponent has to move to the top. Okay, now let's combine these together. I'll use different highlighters here. Okay, look, these both have the same base. When you are dividing, you're actually subtracting those exponents. So this is going to be 8 to the 20 minus 9, which is 11. Now, do I expect you to calculate 8 to the 11th power? Absolutely not, unless you're bored and you really want to. Okay, now the next thing that I see is this. I see an x to the 9th and an x to the 10th right next to each other. Remember, when you're multiplying and they have the same basis, you just add these exponents. This is going to be x to the 19th. 9 plus 10 is 19. And then let's look at those y's. Let's highlight in like this rosy color. Okay, y to the 35th over y to the 12th. When you're dividing, you're subtracting those exponents. So you're going to have y to the 35 minus 12, which is 23. Okay, not the greatest answer, but it wasn't that bad. All right, let's check out number 9. Almost halfway there here. Okay, 5 minus radical 3 squared. Now, you guys, look. If you square this and square this, I will give you 0 points. Okay, that's like the biggest algebra mistake you can make, okay? So please be careful. When you square something and it's a binomial or a trinomial, okay, it's not a monomial anymore, you have to multiply it by itself. So this is 5 minus radical 3 times 5 minus radical 3. Now, I would love if you could do this in your head, but if you can't, don't worry about it. Just work it out. 5 times 5 is 25. 5 times negative radical 3 is negative 5 radical 3. 5 times negative radical 3 is another 5 radical 3. And then negative radical 3 times negative radical 3 is a positive 3. Remember, a square root times itself is just that number. So for example, like the square root of 40 times the square root of 40 is just 40. That's a good thing to know so you don't have to keep multiplying it out. Okay, now let's see if we have any like terms. I see 25 plus 3. Those are like terms, they're just numbers, right? 25 plus 3 is 28. And then I also see negative 5 square root of 3 minus 5 square root of 3, which is just negative 10 square root of 3. And that brings us to the idea that if you're adding or subtracting radicals, the stuff inside the radicand has to be exactly the same. Otherwise, you can't do them, okay? All right, number 10, ew. Okay, x minus 3y cubed. If you cube this and you cube this, again, you will get 0 points. Actually, I will be tempted to give you like negative 2 points because it's that bad of a mistake. If it's a binomial or a trinomial, you have to multiply it by itself 3 times, okay? This only works if it's a monomial that you can like kind of distribute the 3 to everything. So look, this means x minus 3y times x minus 3y times x minus 3y. Is this a fun problem? No, I'll be honest, I don't want to do it either, but we're just going to do it, okay? So look, let's look at these two first. Okay, let's FOIL that out. So x times x is x squared. X times negative 3y is negative 3xy. Negative 3y times x is, again, negative 3xy. You guys notice I'm just putting the variables in alphabetical order. You don't have to do that, but it just looks better. And then negative 3y times negative 3y is positive 9y squared. Now, before I get all crazy and multiply by this, so let's simplify. So what's negative 3xy minus negative 3xy minus 3xy? So you're going to have x squared. This combines to make negative 6xy and then plus 9y squared. Now, don't forget, we still have to multiply it by this last x minus 3y. Okay, now look, this is where the problem gets like super duper long, but look, just go slow. You can do it. It's not that bad, okay? We do different colors here. Okay, so let's take this x squared and multiply it by both of these. So for the first little part, x squared times x is x cubed, and x squared times negative 3y is negative 3x squared y. So we just did the first one. Then maybe in red, we'll take the next term, the negative 6xy, and multiply it by x. So negative 6xy times x is negative 6x squared y. And then negative 6xy times negative 3y is positive 18xy squared. And then the last one, maybe we can do this in like, I don't know, what's a good color? Let's do green, okay? Then 9y squared, let's multiply that. 9y squared times x is 9xy squared. And 9y squared times negative 3y is negative 27y cubed. Okay, combine like terms. Here we go. So there is not another x cubed anywhere, so it's just going to be x cubed. Then negative 3x squared y combines with negative 6x squared y, giving us a negative 9x squared y. And then 18xy squared plus 9xy squared combines to make a 27xy squared. And then this is like another little loner at the end, so it's negative 27y cubed. Alrighty, that was really fun. Okay, number 11, we're almost there. Okay, this one's kind of gross. I can't add or subtract radicals unless the stuff inside the radical is exactly the same. Since I don't have that, let's fix it up. So this is 2 times the square root of. Now ask yourself, what is 27? It's 9 times 3, right? The reason I like this is because this 9 right here is a perfect square root. That's what I'm looking for, okay? Let's look at the next one. Plus 7 times the square root of, well, what does 12 equal? That's 4 times 3. Again, the reason I like that choice is because 4 is a perfect square root. If you chose 6 times 2, that wouldn't work as well. You'd have to break down the 6 again, okay? And on the last one, minus 3 times the square root of. Now you guys, look, they all have to be the same. I'm seeing a little pattern here, right? Look, times 3 times 3. Maybe this is something times 3. What times 3 is 48? That's 16. And that worked out so well because 16 is another perfect square root. So how does this work? Let's do it, okay? This is 2, whoops, that's a highlighter. This is 2 times the square root of 9, which is 3. And then I have this guy left over inside the square root, okay? Do the next one. 7 times the square root of 4, which is 2, and then I still have this square root of 3 left over in my radical. And then minus 3, the square root of 16 is 4, and then I still have the square root of 3 left over in the radical. And notice, like, all the radicals are now square root of 3, square root of 3, square root of 3, which is what I wanted, right? So let's do this. 2 times 3 is 6, rad 3, plus 7 times 2 is 14, rad 3. And then 3 times 4 is 12 rad 3. Now that they're all rad 3s, I can actually combine them. 6 plus 14 is 20. 20 minus 12 is 8. And it's going to be an 8 rad 3. Okay? All right, number 12. This is a fun little problem. Okay, when you're subtracting fractions, you need a common denominator. Looking at these denominators, boy, oh boy, are they almost the same. So remember, if you had one wish in the whole wide world, what would it be? It would be if I could flip these around. But you guys remember we talked about this in class. You can't just flip things around if you're going over a minus sign. For example, 2 minus 3 and 3 minus 2 are not the same thing. One's a negative and one's a positive. So look, you can flip them around. That's fine. But that means you have to multiply everything by -1, which means it's going to change this sign. So if that's a negative, it's going to turn positive. If it was a positive, it would turn it negative. So you can rewrite this as x over x squared minus 25 plus 5 over x squared minus 25. Okay, now my dream came true, or my wish came true. I have a common denominator now, don't I? Look, these are exactly the same. So if my common denominator is x squared minus 25, and they're all x squared minus 25, I don't have to change anything on this. What's x plus 5? It's a silly question. It's just x plus 5. Now look, this would get you some points, but it wouldn't get you full credit because we can still reduce it. Remember, you always want to ask yourself, can I factor and can I cancel? You cannot cancel unless you factor. On this one, you can factor the bottom. This guy is a difference of two squares, which is x plus 5, x minus 5. And what cancels there? It's that x plus 5, right? So what's left over? Now, you guys, the biggest mistake people make is they say the answer is x minus 5. Someone's going to do it. Not going to be happy. Where's x minus 5? It's on the bottom. It has to stay on the bottom. That means what holds its place on the top? Big fat 1. Okay? All right, number 13. Oh my gosh, that looks awful. Now look, when you're multiplying fractions, you can multiply straight across. So on these guys, what you want to do is you want to factor and then cancel. So this is like 4 factoring questions all in one. So I kind of want to cry here, but we can do it. Okay, what kind of factoring is this little guy? Well, that's a big star. So let's do it over here on the side. I need 2 numbers that multiply to give me 12 times 4, which is 48. And add to give me this middle term, which is 19. Okay, now you might be thinking, Ms. Cruzy, I don't know what that is. And it's okay if you don't. Like, if it doesn't come right to your mind, just kind of look at what you got. What times what is 48? Well, I already did it. 12 times 4 is 48. So write that down. 12 times 4. Out of a 12 and a 4, can you get a 19? No, okay? So let's go ahead and break this down. Okay, you guys, what does 12 break down into, okay? That breaks down into 3 times 4, and let's keep this as a 4. Don't break down too many of them at once, and let's see if we can find a better combination. So instead of doing 12 times 4, maybe we can do 16 times 3. Now, out of a 16 and a 3, can I get a 19? Yes, I can, okay? Now look, if it didn't work on the second step, you just have to keep breaking it down and looking at combinations, okay? So 16 times 3 is 48, 16 plus 3 is 19. Hey guys, by the way, I don't know why, but 16 times 3 equals 48 pops up quite a lot. Like, I would maybe just memorize that. That's a good one to know. Okay, what goes in the little wedge? It's my leading coefficient, this lovely 12. And then let's reduce these fractions. 16 over 12 reduces to 4/3. And 3 over 12 reduces to 1/4, okay? So when I do bottoms up on these guys, take that bottom and move it up, I'm going to go ahead and get 3x plus 4. And this guy right here, the 1/4, is going to give me 4x plus 1. That's super gross. Okay, let's look at the other one, though. Oh, my gosh, it's another big star, but that's okay. All right, let's do on the side here. Okay, so for that one, I need 2 numbers that multiply to give me 24 and add to give me that middle term, which is 11. This one's a little bit easier. It's just 8 and 3. Divide by your leading coefficient, which is a 4. 8 divided by 4 is 2. So one of my factors is going to be x plus 2. And if I do bottom up on that one, I'm going to get 4x plus 3. Okay, it should get easier from this point on. Okay, this one right here, what kind of factoring is that? That looks like a GCF to me, right? So let's pull out an x, and we're going to be left with 4x plus 3. And then on the bottom, what do I have here? That looks like a difference of 2 squares. So what times itself is going to give me that first term 1? That's going to be 1 times 1. 1's a plus, 1's a minus. What gives you 16x squared? That's going to be 4x and 4x. Okay, now let's see what we can cancel here. What's the same on the top and the bottom? Well, I see a 4x plus 3. And then you might be like, I don't see anything else. But you guys, look at these two. 4x plus 1 and 1 plus 4x. Remember, it doesn't matter if you say 1 plus 2 or 2 plus 1. It's the commutative property of addition, right? It doesn't matter what order they're in. Those guys will cancel out too. They're the same. So what do I have left over on the top? I have an x from here. And I have a 3x plus 4 left over. You do not have to multiply that out. Please leave it like this. And on the bottom, I have an x plus 2 times 1 minus 4x. X plus 2 times 1 minus 4x. And that's it. All right, let's see if 14's a little bit easier. Oh, it's a division problem. Okay, when you're dividing, what do they say in class 3 to? Like keep, change, flip, I think, right? So we're going to keep the first fraction. So keep that, x squared plus 8x plus 16 all over 2x minus 4. Change, what do we change it to? Very good, multiplication, and then flip. So it's going to be x, no, I didn't flip it. Jeez Louise. That's going to be 8x minus 16 all over x plus 4 cubed. Now you guys notice this just turned into a very similar problem to number 13. Now it's just multiplication. So factor, cancel, 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 and then you're all done. Okay, so what kind of factoring do we have here? A little bit easier this time. That's just a big X. So I need two numbers that multiply to give me 16 and add to give me 8. That's 4 and 4. So this is going to factor to x plus 4 times x plus 4. On the bottom here, I have a 2x minus 4. This is just your greatest common factor. Let's factor out a 2, and you're going to be left with x minus 2. Then on this guy, another greatest common factor. I can take out an 8, and I'm going to be left with x minus 2. And then on the very bottom here, look, this is already actually factored for you. I'm just going to expand it out. What does x plus 4 to the third mean? That means x plus 4 times x plus 4 times x plus 4. Okay, now let's go ahead and cancel stuff. This is the fun part. Look, x minus 2 and x minus 2, done. There's an x plus 4 on the top, x plus 4 on the bottom. Another x plus 4 on the top, another x plus 4 on the bottom. So what do I have left over on the top? Just this sad little 8. What's left over on the bottom? A 2 and a x plus 4. But you guys, can I go further? Check this out. What's 8 divided by 2? That's 4. So this is 4 over x plus 4. Okay? All right, we're almost there. Number 15. We're adding and subtracting, which means we need a common denominator. Now, the process for finding that is you want to look at the denominators that you have and see if any of them factor. So look at the first one. Does x plus 2 factor? I'm sorry, x minus 2? No, so I'm just going to leave it. 5 over x minus 2. Then plus. Does x squared minus 4 factor? That one actually does. It factors to x plus 2 times x minus 2. It's a difference of 2 squares. And then I have a minus sign right here, minus 2 over. Does x plus 2 factor? No, it does not. Okay, so step 1 is to factor all of your denominators. Now, step 2 is to try to find that common denominator. Now, how do we find that? You guys, look at all the denominators. Look at this one, and look at this one, and look at this one. Does anything repeat? I see stuff that repeats. Check it out. X minus 2 and x minus 2. Whatever repeats, you write it down just one time. Okay? Now, what else repeats? Let's highlight it in a different color, like orange. X plus 2 and x plus 2 also repeat. So you write that down once. And there's your least common denominator. Okay? If there were any leftovers, like something that didn't repeat, you would just tag it on and multiply by the leftovers. Okay? Now, my goal is to get every denominator in this entire problem to look like this one, okay? So let's look at the first thing here. I have an x minus 2, but I need it to look like this. So look, it already has the x minus 2. It needs this x plus 2. So let's multiply this by x plus 2. I'm going to go ahead and do it. If I distribute this, I'm going to get 5x plus 10. Okay, then I have a plus sign. Now look at this. I need this to look like this. But oh my gosh, guess what? It already does. That means I don't have to change anything. So just add an x plus 3. And then I have a minus. Be really careful with these, okay? Minus, okay? And then I need this x plus 2 to look like this denominator. So what does it need? It needs an x minus 2. So this needs an x minus 2. Now be careful. Why did I make an arrow here? You're not just distributing the 2. You're actually distributing a negative 2. So negative 2 times x is negative 2x. Negative 2 times negative 2 is a positive 4. Okay? That's where people mess up this problem, so just be careful with that. Okay, now let me erase this because there's way too much going on here. Let's combine some like terms. 5x plus x is 6x. 6x minus 2x is 4x. Sorry, this is driving me crazy. There we go. okay? And then we've got 10 plus 3 is 13. 13 plus 4 is 17. That's the highlighter. And then it's all over x minus 2, x plus 2. And you guys seeing that I can't factor the top anymore, that means I'm not going to be able to cancel, so I'm done. All right? Okay, what have we got for number 16? Oh, this one's fun. Okay, 64 over 125 to the negative 2/3. So let's do in over out. This is your in, this is your out. So I'm going to write this in radical form. I'm going to put the base in there, 64 over 125, okay? The in is negative 2. I'm raising all of this to the negative 2. And the out is this 3. So I want the cube root of 64 over 25 to the negative 2. Now, you guys, when the numbers get really, really big, you can reverse the order on these. This is the same as the cube root of 64 over 125. That whole thing raised to the negative 2. Okay, so if your numbers are big, reverse the order. Cubing something or squaring something is a lot harder than taking like the cube root or the square root because it brings it down. Okay, so what do we get? The cube root of 64. What times itself 3 times makes 64? That's 4. And then the cube root of 125 is just 5. Remember, I told you to memorize those. And now I need to raise this to the negative 2nd power. Let's go ahead and do it. So this is 4 to the negative 2 all over 5 to the negative 2. Remember, no negative exponents, so who has to move? They both do. This has to move to the bottom. This has to move to the top. And now just make it pretty. So that's 25 over 16. Alrighty? Okay, almost done. Let's look at number 17. If I want to rationalize means to make the number on the bottom a whole number. I don't want it to be a radical. So the way to do this is to multiply by the square root of 5. So on the top, we're going to have 50 square root of 5. And remember, a square root times itself is just that number. Square root of 5 times square root of 5 is 5. And notice I can simplify this. 50 divided by 5 is 10. So this is 10 root 5. Okay, let's look at 18. Kind of weird little question here. I don't like this. So I'm going to break this up into square root of 3 over square root of 5. And do the same thing that I did on 17. To get rid of the radical on the bottom, I'm going to multiply by square root of 5. Then what is this going to give me? Well, the 10's still on the outside, and square root of 3 times square root of 5 is the square root of 15. And then on the bottom, the square root of 5 times the square root of 5 is just 5. Again, this simplifies. 10 divided by 5 is 2, rad 15. Okay? All right, number 19. Okay, this one's not as simple as 17 and 18. You can't just multiply by radical 3. If you have a binomial, bye, Gavin, drive carefully. If you have a binomial on the bottom, you want to multiply by what's called the conjugate. The conjugate means just to change the sign in the middle. So the conjugate of 4 minus radical 3 is 4 plus radical 3. But whatever I do to the bottom, I have to do to the top. Okay? So let's distribute this. 3 times 4 is 12. And then 3 times radical 3 is 3 radical 3. Now remember, when you're foiling conjugates, and this only works for conjugates, the middle terms always cancel out. So the trick is just to do first and last, okay? So 4 times 4 is 16. Negative radical 3 times radical 3 is negative 3. And then let's simplify this. So this is 12 plus 3 rad 3. All over 16 minus 3 is 13. And make sure you can't simplify this. You guys, look, 13 does not go into 12 and 13 does not go into 3. So we're kind of stuck. That is going to be your final answer. Okay? All right, last question. A rectangular garden. Okay, so to start drawing a picture. Are you ready? A rectangular garden. Okay. If you're wondering what that is, they're plants. Okay, there's my garden. It's probably what my garden looks like, except they're not green, they're brown. It's really sad. Okay, has a length that is 3 times its width. So here, let's translate that. the length, I'm going to call it L, is means equals, 3 is a 3, times, okay, that means you're multiplying, so times the width, which is W. So basically, the length is 3W. So if this is the length, that's 3W, and then we're going to call this the width, which is the W. Does that make sense? Okay. It is being expanded so that the length of each side is increased by 2 yards. So look, we're going to increase this by 2 yards, and we're going to increase this by 2 yards, okay? So what is this new thing going to be like, okay? Look, if this right here is the width, and I added 2 more yards to it, then that means this new width is just W plus 2. Okay, if the length is 3W and I added 2 yards to it, that means the new length is 3W plus 2. I just gave each one 2 more. So the question is, find a polynomial in standard form that can represent the area of a new garden. Now you might think you never taught us this, Miss Cruzy, but you know what the area is. Area is length times width of a rectangle. You should really know that. Okay, the length is this guy right here, 3W plus 2. And the width is this right here, which is W plus 2. Okay, and then just multiply it out. They want a polynomial. So 3W times W is 3W squared. 3W times 2 is 6W. 2 times W is 2W. And 2 times 2 is 4. Combine like terms, and you're going to get 3W squared plus 8W plus 4. All right, and that's it. You guys, I hope this helps. Hey, this first test is very similar to this, okay? So please, like, try to do well on this first one. Start really well in this class because not all the tests are going to be exactly like the reviews from this point on, all right? All right, hope you guys have a good night, and I'll see you tomorrow. Yikes, what am I doing? Hang on a second.